Hi guys, welcome to Matsi with me, Miss Resi, our teacher for today. So today we're going to talk about conic sections. So what is conic section? So in mathematics, a conic section or simply conic is a curve obtained as the intersection of the surface of a cone with a plane. So let's try to highlight some words like intersection. So it is obtained by the intersection of the two things, which is surface of a cone and a plane. Let's try to draw a double circular cone that I taught you last time, and a plane. So if these two objects will intersect, a curve will obtain. That is a conic section. If a plane intersects a double right circular cone, we get two-dimensional curve of different types. Depending on the angle made by the plane with the vertical axis of the cone, the plane can cut in three different types. The first type is called ellipse. When the plane intersects the double right circular cone in such a way that the angle between the plane and the axis is greater than the vertex angle, we get a closed figure or curve called an ellipse. So let's highlight some keywords. The angle between the plane and the axis. Where can you find that? So here's the plane, and the axis is the broken line from top to bottom. Let's name that angle B. So the other angle is the vertex angle. Remember our vertex angle in the previous lesson? It's located here between the axis and the generator. So it is said there that it should be greater. So if angle B is greater than angle A closed figure or curve will be formed. It will be called an ellipse. So if you will look the top view, it will be like this. When the plane is perpendicular to the axis, the ellipse becomes a circle. Thus, circle is a special type of ellipse. So let's highlight the word perpendicular. So if this plane is perpendicular to the axis, if this is perpendicular, the ellipse will become a circle. The next type is called the parabola. When the angle made by the plane to the vertical axis is exactly equal to the vertex angle, we get an open curve called a parabola at the intersecting surface of the cone. So let's highlight the word angle, plane, and vertical axis. So where can you find the angle made by the plane and the vertical axis? For example, here. Let's call this angle B. Should be equal to the vertex angle. Again, where's the vertex angle? It's below here. Let's name this angle A. So if A is equal to B, therefore an open curve will be formed called parabola. So if you're going to look at the front view here below, it will form a U-shaped curve. The plane intersects only one nap of the double right circular cone as long as the angle between the plane and the vertical axis is greater than or equal to the vertex angle. The last type is called hyperbola. If the plane intersects the vertical axis at an angle smaller than the vertex angle, the plane intersects both the naps of the cone to form an open curve called a hyperbola, which has two disjoint curves. So let's highlight this plane and vertical axis. So if the plane and vertical axis intersect, an angle will be formed. So for example, here let's call this angle B. Should be smaller than the vertex angle, and the vertex angle is here. Call it angle A. So if B is less than A or smaller than angle A, an open curve called hyperbola will be formed. So it intersects both the two naps, the lower and the upper nap. So if you're going to look at the front view, it will be looking like this. It has two disjoint curves, so the two curves are not joined together. So, and lastly, degenerate conics. If the plane intersects the double right circular cone at its vertex, the ellipse becomes a point, the parabola becomes a line, and the hyperbola becomes two intersecting lines. The figure obtained are called degenerate conics. So let's highlight. So the plane intersects a double right circular cone at exactly vertex. The ellipse becomes a point. So let's try to look at this first figure. So the ellipse, so from this angle it moves to exactly at the vertex, so it becomes a point. Another thing, the parabola becomes a line. So from parabola, here's the vertex, intersects the vertex, and that's the line. And lastly, the hyperbola becomes two intersecting lines. So hyperbola will have two intersecting lines, so they will meet each other.